Okay, so just to give you guys a heads up again that these lectures will be posted on Canvas. So if you guys ever need a refresher or you want to listen to my ASMR voice before you go to sleep, although that is a little bit creepy because I don't like my voice, you guys can watch this on YouTube to review the information. Okay, thank you. I appreciate that. That's kind of weird. All right, let's get started. Okay, so before we get started, you do need two things in front of you. You're gonna need the common polyatomic ions. It's gonna be in the sheet protector in front of you, and the periodic table, since we'll be referring to both. So just make sure you guys have one handy, because we will be using it for the rest of the class period. Okay, so last time we met, we talked about polyatomic ions, and I want to kind of review that information because we'll be building on top of that today. So what I want you guys to do is go on the periodic table and just find aluminum's MCI, okay? So hopefully you guys remember the pattern, but there is a pattern for MCIs, okay? You're supposed to memorize this, so if you haven't, make sure you guys do. It is 3, okay? So this is the pattern. Everybody in this column is 1, 2, 3. This column, there's no MCI, -3, -2, -1, and no MCI. Okay, so just make sure that you guys memorize this or you have it written down somewhere because you will need this for all of our assignments and the exam for this unit. Okay, so since aluminum is in this column, aluminum's MCI is +3. So we're just going to go to our notes and write aluminum is +3. Okay, so aluminum's MCI is +3. All right, now we're trying to figure out what ionic compound, what molecule aluminum MCI and nitrite will make. Now nitrite is not on the periodic table, it's on the polyatomic chart. So let's go to the polyatomic chart. Nitrite, make sure you don't confuse that with nitrate. Nitrite is NO2, and what's the charge on nitrite? It's 1, but what kind of 1? Yeah, -1. So nitrite is going to be NO2 -1. Make sure you guys copy it down exactly the way it's written on the chart. You don't want to change up anything, okay? These polyatomics, they kind of come as package deals. You can't mess around with them. They just come the way they are. Okay, so if we have them and they react with one another, which one will I need more of, aluminum or nitrite? Nitrite. Yeah, nitrite, because nitrite is -1, right? So how many nitrites will I need in total to balance out the aluminum? Yeah, 3. That way I can get it to -3. So what I want to do is I just want to put a 3 in front of it to show that I have 3 nitrites. And then for the compound that they make, I just write them next to one another, Al and NO2. But since I use 3, I'm going to put the NO2 in parentheses and put a 3 on the outside. Okay, and there you go. That is the molecule that you are going to make. All right, pretty simple, right? Yeah. All right, so I'll give you guys a second to copy that down. So what we're going to be doing today is we're going to be doing the same thing. We're going to be learning, or we're going to be practicing making these ionic compounds again, but we are adding one thing on top of it. We'll be learning how to name them. So by the end of this lecture, you should be able to write the name of this molecule right here, okay? All right, so any questions about this problem? You guys all look very tired today. Is it a typical Monday?
I woke up at 2.
That's unfortunate. All right, let's move on. So you guys don't need to write this next part down. This is just kind of for review. Last time we learned about polyatomic ions, and polyatomic ions are ions that are made of more than one atom. Okay, you could think of it as molecules that have a charge. So this is a regular ion. It's only made out of one atom, but this is an example of a polyatomic ion. It's made out of multiple. So when these atoms stick together to make a molecule, they get some kind of electrical charge. And this is the table where we can find them. You have it on your desk. Now, they make compounds called ionic compounds that are made of a cation, a positive ion, and an anion, which is a negative ion. And so that's what we did earlier. And what we're going to do now is learn how to name them. Okay, so if you guys flip to your chart, the common polyatomic one, let's go to the bottom table right here. Okay, the naming rules. And so this is what we'll be focusing on today. We're not going to be looking at this bottom one here. So don't make sure you don't cross it out because you will be needing them. But we're going to ignore this section for today, okay? We're going to be looking at this rule and these two rules. Now, the first thing you want to do is you want to write the name of the cation first, the positive one. You always write the positive name first. And then after that, we write the anion, which is the negative one, okay? So when we write the names of ionic compounds, we always write the positive cation first and then the negative anion. So while we do this, let's name the one that we did for the warm-up. We have Al parentheses NO2, okay? So which one of these was the positive one, Al or NO2? Al was the positive one, yeah. Oh, thank you guys. Hey, you guys want to come up and teach the class? I'm sorry. I'm sorry. Okay, so yeah, 3, my bad. Yeah, so these are the two ions. We had Al and NO2, and we said Al is the positive one, right? So we want to write the name of the positive one first. So if you guys look on the periodic table, what's the name of Al? Yeah, aluminum. So we're just going to write aluminum. And that's the rule that's described right here. Cations, they keep their name. It doesn't matter what their charge is. So Al is 3+, but we just write aluminum. Na is +1, we write sodium. Doesn't matter what the charge is, we just write the regular name on the periodic table, okay? Okay, now we have to write the anion. Now we need to figure out, is the anion made out of one element or is it polyatomic? So if we look at NO2, is this made out of one element or is it polyatomic? It's polyatomic, right? Because we found it on that chart. And so if you guys go to the rules, polyatomic anions, they just keep their name. So what was the name of NO2? Nitrite, yeah. So we just write nitrite. And there you go. That's how you write the name of these ionic compounds. So this chemical right here that we did for the warm-up is aluminum nitrite. Really easy. So polyatomic ions are very easy to work with. You just write their name. So since it was NO2, you write nitrite. If it was SO4, you would write sulfate. If it was PO4, you would write phosphate, etc., etc. Okay. All right, now there is another rule that we need to know for anions. And so let me kind of change the example that we were looking at. I'm going to get rid of the nitrite right here. And instead, I'm going to change the formula into something else. Oh, I don't want to buy anything. Okay, so let's say that this is the formula. So instead of aluminum nitrite, let's say that we had Al2O3. Okay, now this is still going to start with aluminum because Al is our positive one, right? And we say we don't change the name of the cation. So we just write aluminum again. Okay, now the anion, the negative one, is going to be O. And so is oxygen one element or is it polyatomic? Is this one element or is it polyatomic? Yeah, it's one element. If you go to the periodic table, you see oxygen. So this is just one element. And so we need to follow a different rule. If it's one element, you need to change the ending of the name and just replace it with IDE. So oxygen, we would just turn oxygen into oxide. Okay, so this name would be aluminum oxide. This chemical is aluminum oxide. Okay. Yes, you should have this in your notes because we'll be doing problems with this in just a second. Okay, so this second rule tells us that if the anion is made of one element, we change the ending to IDE. So look at, if we have Cl, Cl is chlorine. We change chlorine into chloride. S is sulfur, and we change sulfur into sulfide. Okay, so just know that when we have an anion with the charge on it, we just change the ending of the original element with IDE at the end. Okay. And we'll do a couple practice problems now, but that's pretty much all the rules that you'll need for today. Write the cation first. You keep the cation's regular name. And then for the anion, you either change the ending to IDE if it's one element, and or you keep the name the same if it's polyatomic. Okay. That's pretty much it. Do you have a question? Alrighty, guys, let's do a couple practice problems. Again, this is gonna be on your desk. You're gonna have you're not gonna have the naming rules for your exam, but you will have the polyatomics. But you'll have it for the assignment. So let's use it to figure out the answers to these problems. Okay, so let's start with the first one. I'll do the first one with you, and then the second one I'll have you guys do on your own. But let's look at lithium's MCI and chlorine's MCI. Again, if you guys feel confident doing this, you can kind of zone me out for a second and find the answer on your own. But let's go through the first one together. Okay, so if we go to the periodic table, we have lithium right here, and we have chlorine right here. Okay, so what is lithium's MCI based on the pattern? Yeah, +1. So we'll have Li plus. And what about chlorine? What's chlorine's MCI? Cl what? Not 2. What's the pattern here? Yeah, -1. Okay, so chlorine's MCI will be -1. Again, guys, if you guys need the pattern, make sure you guys memorize it. It's up here again, but you guys should review your notes if you haven't memorized it yet. There's also a video called MCI where I go over this pattern. Just make sure you guys have that handy or write it on your own periodic table. Yeah.
What's that? The 3. What would you put?
Oh, +3.
So after that.
No MCI. Okay, so lithium's MCI is +1. Chlorine's MCI is -1. So we're just going to go back to our notes and let's write that down. So lithium's MCI is +1. Chlorine's MCI is -1. Okay, so if we put these two ions next to each other, are they going to balance each other out?
Yes.
Yes, it's +1 and -1. So we put them together and they will make LiCl. You don't need to put any numbers because they balance each other out. Okay, but now we just need to name them. So we know lithium is the +1. So for the +1, we just write the name. So we write lithium. Okay, we know that Cl's name is chlorine, but since this is one element, what do we need to change Cl into? IED at the end. So that would be chloride. Okay, so there you go. This is going to be the name of the molecule, lithium chloride. So this is the name. And this one right here is going to be the formula. All right, and that's basically how you do it. That's going to be your whole assignment today. All we do is just name them. Not too bad. All right, so I'll leave that up there for you guys to copy down, but I want you guys to take about maybe a minute or two to try the second one with the person next to you. I want you guys to use aluminum's MCI and cyanide in order to figure out what they're gonna make. I want the name and the formula just like we did above. So I'll give you guys about 2 minutes to try that out, and then we will move on to the last type of question you'll see on your assignment. Okay. Tripping out. Maybe another 30 seconds to finish up, and then we'll go over it together. Alrighty, guys, let's go over this one and then we'll move on to the last type of problem you'll see on the assignment for today. So if we look at aluminum on the periodic table, what is aluminum's MCI? We already did this for the warm-up, but yeah, aluminum is +3. Okay, so we're gonna go back to our notes and then we're gonna write that aluminum is +3. Okay, now we need to do cyanide. So cyanide is a polyatomic ion. So if we look at cyanide on the chart, what is the charge on cyanide? -1, yeah. Make sure you guys are careful with the positives and negatives. So cyanide is -1. All right, so which one do I need more of, aluminum or cyanide? Cyanide. And then how many do we need in total? 3, good. You guys are experts at this now. So we put them together and then we just write the formulas Al and cyanide next to each other. Since I use 3 cyanides, I have to put cyanide in parentheses and write a 3. Okay, and then for the name, the cation, we just write the regular name, aluminum. And then since cyanide is polyatomic, you don't need to change it to anything, so we just write cyanide. Good job, everybody. Aluminum cyanide. Okay, so the one on the top is the formula. The one on the bottom is the name. And that's pretty much it. Yeah. Uh-huh. Correct. Yeah. Yeah. And cyanide is a package deal. That's why we have to put it in parentheses. Giselle, did you have a question? Oh, okay, for sure, for sure. Any other questions? Okay, yes. Oh, I'll go later. Is it urgent?
Yes.
Oh my goodness. Okay. This is urgent. No, it's not urgent. Okay. Oh, it's okay. Yeah, it's been like that. Thanks for the heads up, though. Okay, let's do the last type of problem. So in the last type of problem, you'll see on your assignment and I guess your exam too in a couple weeks. We're going to be going in reverse. So instead of finding the name and the formula, I'm going to give you guys the name and then you have to write the formula. So let's go down to the end of the notes. I'll do the first one with you and then you guys can try it on your own. But if you guys feel confident doing this, you guys can just go ahead and do it, okay? So we need to write the formula using the name. Okay, so let's start with lithium. Okay, so lithium is Li, and if you guys look at lithium on the periodic table, what's the MCI? What's the MCI for lithium? It's right here. Yeah, +1. Good. So lithium is +1. And then we have phosphate, which is the anion. So we go to the chart. If we look at phosphate, what's the charge on phosphate? -3, exactly. PO4 -3. So we'll just write PO4 -3. Okay, good. All right, we're almost done now. Okay, obviously we need more lithiums to balance out the phosphate. How many lithiums do I need in total? 3, good. Okay, so we put them together and then we'll write Li. Since I use 3 lithiums, I'll put a 3 behind it, PO4. And there you go. This is the formula for lithium phosphate. So it's pretty much the same thing that we've been doing. We're just kind of going in reverse using the MCI and the charge. So you don't need the parentheses because if you only use it for the polyatomics and it looks like we only have 1, so we don't need to do it. Yeah. If you want to do it, you can, but it's kind of extra work for you. And let's just be honest, no one wants to write more stuff than you need to. Yeah. Yeah, but it wouldn't be wrong if you did this either. If you did this, that's not wrong, but it's just extra work. Good question. Okay, I'll give you guys 2 minutes. I want you guys to try this next one on your own. Strontium nitride. I do want to point this out, give you guys a heads up. Just be careful with the name. It's nitride, okay? Give you guys about 2 minutes, and then we'll go over it, and I'll get you guys started on the assignment. Falling out now. I really really need to shake my head. It's getting too long. Kobe became great when he shakes his head. So now I'd be like Kobe. It's like a headband. I was like tying it, it hurt. Yeah, what's up? You good? Okay. Actually, I should go like this. Yeah. Only if they're made of one. So the polyatomic But you don't change one all the time. Polyatomic always. It's a tricky case. That's how I want to just bring it back up. Alrighty, guys. So this one is a little bit confusing. I picked a confusing one on purpose so that you guys had a little bit of help on your assignment. Okay, so let's go over this one. So strontium is really easy, right? You just go to the periodic table and you find strontium. Strontium is in this column. What's the charge of strontium's MCI? Yeah, 2. Yeah, I don't even need to ask anymore. You guys just know. Okay, so strontium is Sr2+. Now, the one I told you guys to watch out for was nitride, because if you notice the ending is IDE. Okay, so this kind of looks like a polyatomic, right? So if you go to the polyatomic list, you'll see nitrate and nitrite, but we're not looking for nitrate or nitrite. We're looking for nitride. So what that means is, if you guys remember the rules, anions that have one element have their ending replaced with IDE. So we see IDE, nitride. So if we look at the periodic table and we look at nitrogen, it looks like nitride. If we change nitrogen to the MCI, that will become nitride. And so this one is actually not a polyatomic. This is going to be nitrogen, just regular nitrogen. And if you guys take a look at the MCI for nitrogen, it's going to be 3-. Okay, so I wanted to bring this one up because it is a little bit tricky because there is nitrite and nitrate. But if it's nitride, it's talking about regular nitrogen, just one element, okay? All right, so we need to balance it out. Hopefully you're able to, if you balance it out correctly, you would have gotten a 3 and a 2. You need 3 strontium ions and 2 nitride ions. And so if you put them together, you have Sr3 because you use 3 of these. And then we would do N2. That's about as hard as it's going to get. If you guys are able to get that on your own, you're in pretty good shape for the unit. It's not going to get much harder than that in terms of finding the name and the formula. Okay. All right. Any questions? You guys good? Okay. Just wanted to give you guys a heads up again that I did record this lecture, so it will be posted on YouTube, and there's a link on Canvas. So just make sure you like the video, smash that subscribe button, join my Patreon and Discord, and I'll put your names at the end of the video. I'm just kidding. I don't have any of those things. All right, but if you guys need it, it will be on YouTube, all right? You guys can get started on your assignment.